All right, the famous alley cat's problem. Right, so he drips, dripping paint bucket, he's taking it back to the store, he holds it out the car's window, letting the paint drip on the ground. Now let's assume that it's dripping at a constant rate, right? So it's dripping at some unknown rate, and the car accelerates at some unknown rate. So we don't know the time, we don't know the acceleration, right? Starting from rest. If the first drop drips, so let's just draw a little picture here. Okay, here's his car, right? The first drop is like here. And then the next drop is like here, and then the car's accelerating, so of course these dots are getting farther apart. 1, 2, 3, 4, 5. We want to know the sixth drop, right? Okay, so if the first drop drips when the velocity is 0, and the second drop is 2.3 meters, right? How far is the sixth drop down the road? So we want to know what that distance is there, right? Let's draw a nice vertical line.
Stephen Simmons and
Hey.
Brian Thompson, will you please call 5631?
5631. Yeah, say it again. There you go.
Will you please call
That's good.
5631?
I don't know if you got that, but they're supposed to call 5631. Okay, so now I must do something about that speaker. Okay, so here's what we're going to do. I know that the x on this thing is 1/2 at squared, right? And that's because the initial velocity is 0, right? It really is VIT plus 1/2 at squared, but the VI goes away. So here's what I'm going to do is I'm going to set up two equations. The first one is, and I don't know A and I don't know T, but the first one is that 2.3 equals 1/2 some unknown acceleration times some unknown time squared, right? Now, the sixth drop here, this is one of those times. This is 2, this is 3, this is 4. This is actually 5 times later, right? So if this is t, the other drop, the exit drop, right, the one that's the sixth drop, is going to be 1/2 the same acceleration, but it's going to be 5t squared. If t was the time it took for the first drop to drop, it's going to be 5 times as long when the sixth drop drops, right? Because this is first drop, second drop, third, fourth, fifth, sixth, right? So now we've got two equations and two unknowns, right? The slickest thing to do is to just simply divide these guys, right? Because there's something in math that says if A equals B and C equals D, that A over C equals B over D. So I can go, if this equals this and this equals this, then this over this, right? So this is what a linear combination or something for systems of equations. So the half goes the way of the bison. The A goes the way of the bison, right? And of course this bottom becomes, you end up with, let's draw a little line here. You end up with 2.3 over x equals t squared over, and then 5t squared is 25t. 5t, the quantity squared, is 25t squared, right? And then of course now here's the beautiful thing, is that the time goes the way of the bison, right? And now we don't even know. There's still a 1 here, right? Okay, so now we're set. We can go, I guess we cross multiply, right? So we go 2.3 times 25 equals 1 times x. Oh, there you go. That's easy. So 2.3 times 25 is 57.5. So x equals 57.5 meters, because that was meters.